Whether the series converges or diverges, sum of k factorial over k to the k. For this, we're going to use the ratio test. So we're going to look at the k plus first term over the kth term. And then take the absolute value. So now the first fraction will have the numerator of both of the fractions, one on top of the other. And really the absolute value here is not needed because these are all going to be positive. So it's k plus 1 factorial over k factorial times, and then it's going to be the denominators. So it'll be k to the k over k plus 1 raised to the k plus 1. Now a lot of things cancel. So we have k plus 1 factorial over k factorial is k plus 1. And here what we'll do is we'll break this up as k plus 1 to the k times k plus 1, which k plus 1 is going to cancel with the k plus 1 there. And then we're going to bring in k over k plus 1 under the kth power like this. So at this point, I'm going to rewrite this as k plus 1 minus 1 over k plus 1. And that's going to be broken up into two fractions. Basically, this will be the cutoff point. So the first fraction will be k plus 1 over k plus 1, which is 1, and then minus 1 over k plus 1 to the kth power. In order to solve this limit, we want to rewrite this as e. So the limit as k approaches infinity of e to the ln of 1 minus 1 over k plus 1 to the k. Because whenever you write e to the natural log, that's just whatever the function is. And then the exponent comes in front of the natural log. Actually, before we do that, we should bring the limit on top. Let's just do that quickly. And then I guess we could combine that. So we could bring the exponent in front of the natural log. And then at this point, we're going to rewrite k as 1 over k. Because now we can use L'Hopital's rule, because we get 0 over 0 here. So we'll take the derivative of the top, so that's 1 over 1 minus 1 over k plus 1, times the derivative of 1 minus 1 over k plus 1. Let's see, so that would be 1 over k plus 1 squared. And then derivative of 1 over k is negative 1 over k squared. So let's rewrite this now. We have e limit k approaches infinity. So this negative 1 over k squared is going to be on top. So negative k squared over 1 minus 1 over k plus 1 times k plus 1 squared. And I'm going to distribute to negative k squared, and then let's see, 1 minus 1 over k plus 1. Actually, let's just distribute the k plus 1 squared. So it's k plus 1 squared times 1. It's k plus 1 squared minus k plus 1 squared times 1 over k plus 1 is just k plus 1, like that. But here it's pretty obvious that, you know, this is basically be negative k squared over k squared, which is negative 1. So if you want, you can, you know, keep going like this. So it'll be k squared 2k minus k plus k, like that. If you were to expand it, and then you divide everything by k squared. So you have negative 1 over 1 plus 1 over k. This goes to 0. You have e to negative 1 as your limit. that's 1 over e, which is less than 1. And so because the limit is less than 1, it converges by the ratio test.